Are we good to go?
Yeah, also with video.
Video as well. Oh dear, that's not very good, is it? Is that working now?
Yes.
Okay. Do we just continue? Very well. Well, sorry for the online people who missed that. You looked at some slides populating themselves. Very briefly, yes, talked about who I am. This is my company. I work here. Why are we here? Well, we did training, so we can kind of teach a little bit. And we do stuff with Riak, which then became OpenRiak, and we help make stuff, and it's cool. So, what is OpenRiak, which might actually be relevant to quite a few people here today? So, let's break it down. What is a distributed system? Anybody? What's a distributed system? Anyone? Yes, please.
System that runs on separate computers.
Very good, thank you. I like that. That actually works very close to what I got. Anybody else? Something about distributed systems?
That's pretty much the same answer.
Very well, okay. So let's put it in the context of distributed database. So what we do, we share the data between machines. We commonly store multiple copies of data. And the reason you do that is, let's say one of your nodes goes down. Oh, that's strange, I've lost a drink. One of them goes down, you've still got other copies elsewhere, so things still work. So rather than having one node goes down, everything dies, you have one node goes down and oh, I can still work. It usually will have some ability to scale. You can either scale by having a bigger box, vertical scaling, or you can add more boxes to scale horizontally. And of course, because it's a distributed system, it can process vast quantities of data because you can just stick a lot of boxes together and they work. So, of course, when you build a system like that, what could possibly go wrong? Well, conflicting writes. If I'm processing, I don't know, 1 million queries a second or 10 million queries a second or whatever, I mean, they're quite common, 2 conflicting queries come in at the same time. I have a list with 400 items, maybe item number 11 is different between the 2 lists, but the rest match. What do I do? That's a conflicting write. Network partitions. Do this. Pretend this is my cluster. Pretend there are 5 nodes, please, but I just don't have that many hands. So let's say there's a network fault. One of the switches breaks or a cable breaks or something. So suddenly I have a partition where I have 2 nodes here and I have 3 nodes here. If both systems can continue running in parallel to each other and continue serving data, that's great. But what happens when you join them back together? That's a network partition. Performance spikes. Well, that's self-explanatory. Suddenly everybody dumps their data at once. Oh, everything exploded, game over. Hardware failure. Again, classic one. It runs on hardware. Hardware grows old and dies. That's life. And of course, the most dangerous thing in computing in the world, humans. So, let's talk about that in contributed distributed systems. So one of the biggest problems we see in distributed systems, and this was also related vaguely to performance spikes, is scale. People make a great POC. Hey, look, this is my system, it works. Yay, I'm happy. And then suddenly there's huge amounts of growth and it's not quite ideal anymore. So, in possibly the worst segue you will see in this entire conference, we'd like to talk about sharding next. And what is sharding? Well, when you've got a database that grows very rapidly, you need to think about who has which pieces. So if we pretend that our company mascot Chiochan, who is here, 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 and here in various poses, is a server, and we look at the broken mirror and we say, well, you can have a piece, maybe give you 2 pieces, and then you can have some, and everybody can have some. And look, we've got 4 people holding 2 pieces apiece, that's all the pieces, so we are completely covered, and everything's great. That's a nicely distributed system. Every single server has the same amount of load shared between all of them. Everybody agree? Yep. Okay, so let's say, well, everything's getting a bit busy. I need some more capacity. I know, I'll add another node. So we add another node. And we say, well, I got no partitions. Give me a partition. So we get a partition. Is that now an equally distributed system?
No.
No. How can we make that a equally distributed system?
So number of nodes, number of pieces, or maybe equal number of workloads to everyone.
yes, well, to do that, I then need to grow that to 8 nodes. But let's say I don't have enough capacity then, what do? I introduce the 9th node and we're back where we were.
And like the middle.
Exactly, thank you very much. Yes, that's the way we do it. We shatter things a bit more and we give everybody a shed load of nodes and we're all good now. And this is the thing is, in one example we had a second ago, we had 4 nodes with 25% capacity each. But then when we added the 5th node, we then ended up with 2 nodes that only had 12.5% of the total amount. With this one, even if the sharding is somewhat skewed, so let's say this one has 30, this one has 31, this one has 29. The percentage difference is minimal. So, performance-wise, it's still close enough to equally distributed that we don't care anymore. And this is to do with deciding a sufficiently large sharding amount for your database. But the flip side is, you don't want to go completely nuts. So let's say each one of my nodes suddenly has 10,000 partitions. Then the chances are I'm spinning up so many processes to look after each of those partitions, my node may fall over before I actually get up to the right number. So you need to think where you plan to scale to and how you plan to scale out in advance of designing your distributed system. Another one that you need to think about is fault tolerance. So here we have a nice friendly cluster. We have a 5-year cluster, which is very standard. We recommend this number for production if you're using OpenRiak, or more, of course, not less, or any more. And so everything has roughly 60 to 50 to 60% CPU usage. It's ticking over nicely. It's all great. Now let's say one of our servers decides to explode in a fireball of logic. And we've lost our server, it's gone down. This happens, like happens, hardware dies. Or if you're using something like AWS and you have ephemeral storage, somebody turns it off, whoops. So, all the other nodes take over. Roughly, if you take the percentage for that, you add it to the others, it works out like this. Everybody's happy again. We're still running our system, everything's good. And by this point in time, usually your tech support staff will have noticed something and said, hey, we need to do something about this. So what they do is, well, send in their highly trained engineer and say, server 4 has a problem. Take it out of the rack, fix it, put it back in afterwards. And the engineer goes, yes, and they promptly unplug the wrong server. Anybody here has done that before? Really? Wow, you guys are good. Or you don't touch hardware, one or the other. Very well then, everybody. Yes. Okay, well, I've done that before. It's embarrassing and it happens. So yes, so they unplugged the wrong server, which means, oh, whoops, but we're still live. The load from that one is then transferred to the others, and everything keeps ticking over. This is how a fault-tolerant distributed system should work. So, yay. To see this in action, this is a standard one. We took a cluster of React nodes, we took one offline, we waited for a bit, we turned it back on again, and this is what happens. So we see we killed the node here. The red one is the React cluster, by the way. The blue one is a control cluster, which is another React cluster that did nothing. It just kept running as normal. And this is, bear in mind, we're banging the updates through this. This is how many million updates we're throwing through this cluster at the point in time. And how many transactions per second that are happening on the left. So we killed the node, and there's a huge drop in functionality. All the other nodes go, oh, one of the nodes has gone down. What do we do? I know, well, spin up virtual partitions to cover for the ones we just lost out of the entire system, and we'll take over nodes. So we have the initial one where we're busy doing partitions. We then have the partitions are all done, so the cluster takes over as normal. We start the node. There's a slight dip as they then say, oh, we have to give you all your data back so you know what the changes are. The node then comes fully back online, and we're looking good. In the next example, we do a slightly more aggressive one. So we kill the node, same as a minute ago. But then we wait for a second and we nuke the data. So maybe we wipe the disk that holds the data, or for it's Amazon, you use ephemeral storage and we turn off the node instead of restarting it. Oops, been there, done that. And your data is all gone. Oh dear, what do we do? Well, essentially OpenRiak handles that as well. So your node is restarted and it comes up and says, hey, I'm back. And oh, I have no data. Whoops. What do we do now? So the other nodes again come through, they say, here's your data back, and it will copy across all the virtual partitions it's had until the node is able to fully repopulate itself. And then once it's repopulated, recover complete, and we're back to normal for performance, which is still kind of sweet. This is all fully automated. Let's see it. Yeah, this is a horrible graph, I know, sorry. But if we look at this side here shows the same example we saw a second ago. So it's zoomed in on the time where we actually killed the node and killed its storage. So we see how the yellow node is the one we decided to attack. So the yellow node goes down, and then we put power in and it comes back up for a second. It says hello. And this basically shows how the purple node and the brown node, remember earlier I said that we have 3 copies of the data everywhere. So the purple node and the brown node have the other 2 copies. And the yellow node went offline, so stuck there. So they have to take over queries for that. The flip side of this is that once they start doing queries, you'll notice how the amount of load they handle comes back up until everything's back to normal at the end. And the title for this, which I should point out, is this total queries served. And there's a reason why it's different. Within OpenRiak, as I said earlier, let's say you write to this node. I've just touched the screen. I hate touch screens. What have I done? Okay, so you write to this node, and then it will say, oh, I've got new data. I shall tell the other 2 nodes that talk to me about it, and it shares the data with those. So we've got both the external queries, which goes to the client or the application or whatever you want to call it, and we have the internal queries that go between the nodes. And if we now look at what happens at the same time here with user-facing queries. So user-facing queries are the queries that go out to the outside world, whereas the queries we saw a second ago were the total number of queries served, which, as you saw, was slightly different. And this is where it becomes interesting. So within OpenRiak, we have a feature where essentially we have an auction, where a new piece of work comes in, or a new query comes in, and nodes say, hey, I see that. Who can take this? And this is one done by availability. So a node that's not doing much will go, hey, I'll have that, and it grabs it very quickly. Whereas a node that's very busy, for example, nodes that help restoring another node, say, I'm kind of busy here, but I'd like to get, no, I missed it. I got that one. So you end up with your least busy nodes serving the majority of the queries, and your busiest nodes serving the minimal number of queries to make sure that overall performance is affected as little as possible. Which is why we see how the purple node and the brown node, suddenly the amount of user queries they serve drops like a stone. And as soon as the yellow node starts to come on, it pops up and goes, hi, I'm here, I have nothing. And the second later, oh, I've got a tiny bit of data. If there's a question on this data, I can serve it for you. For everything I don't know. And the way that queries work in OpenRiak is it comes in and it hits node number 1. Well, any generic node really. And the nodes all contain a shared ring. So every node knows where all the data is. So your query will come in and it'll say, yes, I've got that, here you are, or I don't have that, but I know a node that does. And it passes your query internally to another node, which will then retrieve the data, pass it back, and that'll pass it back to you. So even the slowest queries in OpenRiak only hit 2 nodes before they come back to you. And that's what's happening here. So as soon as the yellow node is starting to come back online, it's happy to serve whatever little data it has. And as it gets more and more data and the restoration is completed, then it goes back to serving a standard amount compared to everything else. If you put one on top of the other, you can see how the 2 of them phase over that period. Yeah, one other thing I should probably show you very briefly is a node replacement. So of course, we talked about hardware, and occasionally hardware gets old. I've decided I want to replace my old boxes with new boxes. So rather than taking my system down for a maintenance window and making all my customers unhappy, I can actually do this live in OpenRiak. So I say, well, this is my old box, and this is my new box, and I'm going to say to you, I'm going to take you out, I'm going to replace you with this one, take all the partitions from that one. And that's exactly what we do. So we start the node replacement. So the old node, so we had node 4 die earlier, let's say, well, node 4 is clearly not reliable. We're going to replace it with a new node, which we'll call node 6. So then node 4 hands off all the partitions to node 6, everything comes back, and we're good to go again. And again, if we're just going to add a new node, we're going to scale up horizontally. So same kind of process here. We add a new node, we have a small drop in productivity of all the nodes saying, well, we need to reshuffle all the partitions between ourselves and give them to some new node. So the reshuffle happens, there's a slight dip in performance, but as soon as that's completed, they start handing data off, everything becomes much faster and more efficient. Right, other features I should probably mention quickly, active anti-entropy. Who here has heard of things like bit rot? Okay, right. Let's cover that first. So, bit rot is a fascinating process where, especially on magnetic media, it can happen in other media as well. Basically, data that was stored a long time ago, as you know, when things are stored to disk, they're stored in binary ones or zeros. So that's done with charge. You charge it, so it's charged up to a 1. And then when your disk is ready, it goes, well, that's above the charge level, so it's a 1. And that's below the charge level, so it's a 0. And the thing is that because it's charged, what does charge do over time? During entropy?
Discharge.
Yes, it slowly discharges over time. It takes a really long time, but it happens. So if you have, I don't know, let's say, for example, you store a 4 terabyte backup file and you stick it in somewhere like OpenRiak. And because it's a zip file, you have one bit go bad and the whole thing's lost. So you store it in here and you put it there and it's great. And then 7 years later, the auditors come in and say, we'd like to see that file, please. Oh, that's in the backup. So I'll go and and this is the hard way to learn about bit rot. So what OpenRiak does is it has a system called active anti-entropy. Well, what that does is it goes over and it constantly reads the data in your database in the background. It doesn't spy on you, it just says, what is this, does this match that? So actually it will compare the differences. So let's say that we're using our example of 3 nodes again. So this one says, hey, this one should be this. And this one says, yeah, I agree, that should be that. And this one goes, what are you talking about? It's this. And the OpenRiak will say, well, these two agree, and this one does not agree. Well, therefore, chances are that these two can't be corrupted the same way. So probably these two are right, and this one's wrong. So it will then overwrite the one that's wrong with a value from the two that are correct. Which means that even if you get bit rot on one disk, then it will come through and go, hang on, that's different, we're going to fix that. And because it's a fresh write, then it's being pushed back up to the correct charge. Theoretically, whether it's actually the same bit with the same charge, I don't know, but it rewrites it to disk. So it's possible it's the exact same one, but in reality, it may not be. But either way, it goes through and it goes through, yes, determines the correct version, writes it out at all nodes.
Sorry.
Shoot.
So what happens if the 3 don't agree?
If all 3 don't agree, then you should probably manage your hardware better.
So it raises some kind of user error. Or
Yes, so one that will generally, in a case like that, OpenRiak, it will not see that as a sibling. Generally, you will receive an error for that if you want to get a. Okay, you're going to have to go into a bit of theory here. Okay, so there are different ways you can query OpenRiak. So the standard way you query is you throw a query at it, and whichever node replies first is taken as your correct answer because anti-entropy should fix everything for you. Therefore, it should be correct no matter which node you hit. However, if you want to do a guaranteed everything is the same query, then you can say, I want to query maybe 2 or 3 primary nodes, this value, to make sure that they're all the same. And when it comes back, if there's a difference, then that's where we'll run into the same problem and it will probably flag it as an error. So in that case, if your hardware is falling to pieces, that might be the case and you will start to run into errors, but hopefully you should fix your hardware before you get to that level. Other stuff I should probably mention, yes. So as we talked earlier, OpenRiak does not just make a cluster out of a couple of nodes. It will also allow replication between multiple clusters. So that can be unidirectional, where I am a read-write cluster, and the cluster over there is a read-only cluster. So this one does all the processing and stuff, and it's got big fancy machines, and this one's read-only, so we give it tiny machines because it's read-only, it doesn't need to do any processing. And then this cluster says, hey, I have new data for you, the other one says, thank you very much, I'll show that. We also have bidirectional, which means we can do things such as a live. You write to that one, it then shares the data with this one, you write to this one, it shares the data with that one, and everything works great. You can also do multi-direction as well, depending on how crazy you're feeling. There's a lot of flexibility within this. You can also do things that have different queries can sync different data. I'll cover this more later, but an example, everybody here familiar with GDPR? Do well, nice job today. Okay, right, data privacy. So in the European Union, there's a law which is basically called GDPR. And what it says is that personal data about European citizens cannot be stored anywhere outside of Europe, which can make life difficult. So let's say I'm a big US company and I have this awesome system and you have many users, and I also have customers in Europe, and I can't store any data about them. I don't know who they are anymore. Well, that's going to be a problem. So before this law was in place, you'd have a cluster in America, a cluster in somewhere in Europe, and they'd share data with each other, and everything would be wonderful, and everyone was happy. When GDPR kicked in, then you run into the problem that the data in Europe is not allowed to leave Europe, but you still want to share as much data as possible. So what you can do is you can build a specific queue within OpenRiak to say this data should be copied to the US, and this one should not. Which essentially means that from the application developer's point of view, all they need to do is say, well, yeah, that's European data, so stick your GDPR bucket. It's not actually called the GDPR bucket, you can call it whatever you want, but basically stick it in a bucket that replicates on this queue or does not. And that means all your US data you can then sync to Europe, but the European data, you can only sync the safe stuff to the US. And that all happens automatically in the background. So that's one of the advantages with different queues. As well as this, we can also do things such as to do all the replication. We have a reconciliation engine, and you can also connect external things to it. For example, OpenSearch. Quick check that we know OpenSearch. One. Very briefly, what does OpenSearch do?
It's the open source version of Elasticsearch.
Yes, that's good enough for me. Thank you. Right, so one of the things that you'll run into a problem with React is OpenRiak is limited on things like fuzzy searches. Find me a city with a letter O in it. That's really hard to do in NoSQL because it's not designed to cover with stuff like that. NoSQL works really well with direct queries. For example, get me a list of cities within Japan. Easy, I can do that because I have a list that has all the cities in the world and these are tagged with Japan. So I just find Japan and it says, hey, here are your cities, go. But if I want to do a flat one, I have no idea how to do that. Just doesn't work. We can't do the equivalent of SQL star O star. Doesn't work in real. No, bad, do not do that. But if you connect an external engine like OpenSearch, suddenly we can. So what we do is we use the power of OpenSearch's indexes to index everything in React. But to be perfectly honest, OpenRiak scales really well compared to OpenSearch. So you have a huge database I won't say you can't search, you can't do fluffy searches with, and you have this incredibly powerful search engine that doesn't scale to incredible scale that well. So we take the search bit from this, which is awesome, and we take the scaling bit from that, we plug them together, and you've got a really fine system. Right, moving on, system architecture, and this is where I have an example of an absolutely nuts setup you can do with OpenRiak to give you an idea of the possibilities available to you. So we're going to start off, we're going to say that's us, we are a client or an application or whatever you want to call it, something that talks to OpenRiak. And we're going to say, well, we're going to have one main cluster and another main cluster, and they can replicate between each other. Everybody good so far? Well, I forgot where I am, so I think we need labels. Right. So we're going to extend this, and not only are we like that, we are a company that has a whole bunch of labs that run mini clusters within themselves, and they need to share some data with each other, but not everything. So here's a bunch of labs. I am really this nuts. So let's stick them out. So first of all, we take our user, and we set up 2 central clusters, and we stick labs, and this is, call it geolocation. These ones are near that one, so they may as well talk to that one. Those ones near the other one, may as well talk to that one. And we set up replication. Central A talks to Central B talks back to Central A, they share data between them, so whichever one you talk to, everybody has the same data. Yeah. From there, we then add replication in a similar way between each lab. This can be unidirectional or bidirectional, but labs, they want, let's say this lab here, because I can reach it, this lab here doesn't need to know all the data in this lab. In fact, chances are they do research on completely different things and have no interest whatsoever in each other's data. But maybe this lab here and this lab here, this one might do the research first, and then the results of that are actually fed into the tests run in this lab. That's actually perfectly reasonable. So in these cases, maybe it should be bidirectional, where the data from this one is syncs up to here, syncs through there, and syncs down to there. Or it could just be unidirectional, where I don't need any data for anywhere else, so I'm just going to dump straight into here, and that's it, I'm finished. But the two main ones know about everything at all the different points in time, and the user can quite happily talk to central A or central B, or we could even have a load balancer up, so it would just be completely random on which one we talk to in the classic one there. And because everything on one side can talk to everything on the other side, then everybody's happy no matter what happens, and short of a complete network loss, which in this case would probably involve the entire internet going down, we would expect it to continue working all the time. And we actually see customers run clusters not quite this complicated, but we do see ones where you'll do things such as you'll have maybe one cluster in the West Coast, one cluster in mid US, and one cluster in the East Coast, or you have people with one in the US, one in Europe, and one in Asia, to make sure that it's always have something up. And even if one cluster in the country goes down, you just point it at the other ones and it still works. It's just a tiny bit slower. And that's network lag, nothing to do with OpenRiak. So when should you use it? People who use it, financial institutions. Believe it or not, they do. One of our largest customers is a financial institution. It's a bank. Every single transaction the bank runs goes through OpenRiak. So it's definitely stable and reliable enough. I admit they copy a lot more numbers of, they don't have 3 copies, they have a lot more copies. But essentially, yes, it's perfectly usable. Government organizations, I know of a National Health Service that does this. E-commerce, one of our customers is Japan's second biggest online retailer. Manufacturing, one of China's major electronics manufacturers runs on OpenRiak. Messaging, people may not be aware of this. Apple used to run iMessage on Riak back in the day. Line, which is the most popular messaging tool in Japan, runs on OpenRiak. IoT, there's another obvious one. If you've got 10 million devices all around the planet, having a central reliable database where they can throw stuff at any time, hit any node, and it still works, is a very useful way to store stuff. Especially if you're doing hundreds, if not thousands, of transactions every single day. So, usage advantages. OpenRiak runs on cloud or commodity hardware. How commodity are we talking here? In Japan, I have to file taxes on cryptocurrency. That means for every single transaction I make, I have to register it with the Japanese tax office saying how much was the transaction for, what point in time did it happen, and what was the equivalent in Japanese yen at that point in time, which is an absolute nightmare. So I wrote myself a piece of software to do this, and what I do is I basically grab data about all the different cryptocurrencies in the world. I grab details about all different exchange rates in the world, and I stick it in an OpenRiak cluster that runs on Raspberry Pis. So I have 5 Raspberry Pis with USB 4 terabyte drives, and it just ticks over. I mean, to be fair, it went down once, but it went down because I unplugged it to my house. But other than that, I've had 100% uptime for 7 years now, which that's pretty good in my opinion. But yes, people often run it in slightly bigger boxes. I run a copy on this laptop for when I'm doing test work. It will run as a single node, but please only do that for development work. Otherwise, bad things can happen in production. Lose your node, you lose everything. It's horizontally and vertically scalable. Add more boxes or just have bigger boxes. It's fault tolerant and eventually consistent. Does everybody know what I mean by eventually consistent?
Yeah. There might be some difference in data between 2 clusters, but eventually they'll come to the same.
Yes. Essentially, this relates back to CAP theorem. Pretty familiar with CAP theorem? Okay. So CAP theorem is an absolutely fascinating idea where you have consistency, availability, and network partition. CAMP is just, no, let's not go there. So the key C part is consistency, which means that if I talk to this node, or this node, will it give me the same response? Availability is, are all nodes available at the same time? And network partition is, will it continue to work if there is a network partition? And of course, the challenge with CAP theorem is it's meant to be theoretically impossible to have all 3 at the same time. If I write something to this node here, I can't guarantee it will be straight away at these nodes. If I do guarantee all nodes will give the same response, one of my hardware things died. My system's no longer fully available. It's one of these, you can, but the best you can do too. So OpenRiak is designed in a way where we do accessibility and functioning in a network partition. That's what we do out of the box, which is why we have to be eventually consistent, which is exactly as you said. You wait for a bit and then it will come back together and everybody will have the same. Right. And also, as we talked about a second ago, we have geo-redundancy. You can build a cluster here in US or another one in Asia and do things like that. And one of the other reasons that people use OpenRiak is GDPR and Cloud Act avoidance. We talked about GDPR a second ago. Anybody know the Cloud Act? No? Okay. This is a fascinating piece of US legislation. So in 2016, America decided that they can talk to a cloud provider, Amazon, Azure, Google, whoever, and say, hey, we'd like to have all your data on this place. Which, that's kind of common in America. It's the kind of thing you expect. Anybody will give everything to the American government because they're Americans and it's very patriotic. Woohoo, great, okay, I have no problems with that. The problem comes when the Cloud Act specifies that the American government can talk to any American company and ask them to give any data they have on any client anywhere to the American government, and they don't have to tell the client that the data was given. That suddenly becomes a lot more interesting, doesn't it? And a classic example, so what was it? A few years ago, there was data stored on an iPhone that was held in a data center in Ireland. So Apple said, we're not going to give you this because it's in Ireland. And that's not right. In the US, we can give you the data, but that's under Ireland, so we can't. And there was a huge legal trial and stuff about this. Cloud Act gets around that. American government can now say to them, well, hey, Apple, I want this data. Fetch. And Apple will say, well, we really don't want to give you that, but you kind of got our hands tied. Yeah, okay, here you are. And this is why you may want to use something like OpenRiak. Of course, if you run it on Amazon or let's say you use an online cloud service, for example, DynamoDB. If your data's in there, then Amazon can say to you, hey, DynamoDB user, US government wants your data. And that can be even if you're a European company or an Asian company. If you use DynamoDB, then anytime the US government can steal your database. Well, steal is probably not the right word. Copy your data and do research on it. For whatever legal reason they justify at the time. Whereas if you run it on your own hardware, that's not going to happen unless you're in the US, in which case you're legally required to do that anyway. So that's your choice. Anyway, that's Cloud Act, and that's one of the reasons why you might want to consider not using services that are liable to be hit by that. Which is why hyperscalers are actually surprisingly dangerous in this day and age, assuming you want to make sure your data for your people are private. And of course, another way to do that is OpenRiak can run in an air-gapped environment. How do you stop your boxes being hacked from somebody on the internet? Well, you unplug the internet. That's surprisingly hard to get through. And that's the other thing that's unique about something at the scale of Riak is, let's see DynamoDB do that, and the internet has gone down and my database has gone away because it's somewhere on Amazon and I can't reach the internet. Whereas this one here, well, it's just a box there, it works fine. Right, so why is OpenRiak insecure out of the box? There's actually a very good reason for that. It's easy to set up, assuming you're not afraid of the command line, which some people are these days. Basically, how do you set up OpenRiak? Well, I download the binary, I install it, and I say start. And that's it. I suddenly have OpenRiak running. I mean, to do everything else, clustering and setting up your data and how you want to structure it, that's a bit more complicated. But the basics are download, install, start, go. Everything's good. And that's why it's insecure out of the box. If you wanted to do a fully secure version of a fully secure version of OpenRiak, that takes a bit more work. And if you get it wrong, then suddenly you lose access to everything until you undo whatever mistake you made a minute ago. So, what factors are there within OpenRiak that apply to your security? First of all, I'll explain these all in a second. We have EPMD, which is Erlang Port Map daemon. We have HTTP queries, which sounds innocuous enough. And we have user permissions. I'm going to go through and explain why this is an issue and what we can do about that. So just a second. Oh, maybe not. There you go. So EPMD is the Erlang port map daemon. Does anybody know what this does? Anybody here know Erlang, by the way? Programming language. No one? No. Wow. It's a great language. Look it up. Erlang is originally used for telecom protocols. It's a ridiculously stable distributed system. I mean, to give you an example how stable it is, when was the last time you had a phone call crash on you? Precisely. This was developed in the 1970s to run essentially switchboards, and then it became more and more advanced. But the same basic distributed stability has been there for years and years and years and years, which is why things that are run on Erlang, they're not designed to crash, they're designed to fail and recover, which is very different to how much modern software is. It works and works and works, and it fell over. We have to do a full stack trace to find out. In Erlang, it fell over, but it restarted itself and it continued. Which is why you don't have phone calls crash on you. If something's going to crash on you, it's going to be your smartphone or the application running something or something else crashed or whatever. The chances are the actual phone call itself will not crash at all. So, what EPMD does within Erlang is, as Erlang is a distributed system, I need to be able to know what everybody else in my cluster does, because I know nothing. It's a bit like, we have a great bunch of people come to listen to my talk and I know almost nothing about any of you. Sorry, but it's true. And probably you don't know that much about me either, which is fair, but still weird. So what does it do? Basically, it tells other nodes about what's available. So if you come and talk to me, I'd say, hey, I'm an EPMD. And these are all the ports available on my Erlang box. Please feel free to come and talk to me when you want to. And that's what EPMD does. It's a required function for React to run. It's a distributed basis. We have database, we have to talk to the other nodes. That's life. It communicates with a shared cookie. So, it's not completely unsecure. If you know the magic word, I will tell you all my ports. If you don't know the magic word, I will not. And the problem with OpenRiak is the default cookie for over 17 years now is Riak, and that's published all over the internet. So if I come into a default stand-up version of Riak and I say, hey, are you Riak? Because yes, I am, here are my ports. And that's horribly insecure. So yes, why is EPMD a risk? So let's say a malicious third party gains control of the cookie. What will that incur? Well, first of all, the malicious third party can then communicate with other nodes within your React cluster. You get full node discovery, as it not able to tell you about the other nodes, it'll tell you what ports available, they know everything. But of course, once they have access to the cookie, a slightly more advanced person will actually be able to use that to attack an OpenRiak node and overwrite low priority functions. Which of course means they can inject malicious code. But not only can they do that, they can also issue malicious Erlang commands. So not only can they take down the database from inside, but Erlang allows you to execute system level stuff as well. So they can then issue malicious OS level commands to do everything from phone home to install a rootkit to whatever. That's kind of bad, really, isn't it? Let's talk about HTTP queries. So, OpenRiak listens for HTTP requests by default. Initially, it actually has two interfaces. One is HTTP, the other one's protocol buffers. Binary versus standard. And they're both available by default. So, anybody see a problem here? HTTP supports create, read, update, and delete. Standard API, you'd expect CRUD operations, yeah? Anybody see where we're going with this yet?
Send malicious requests.
Oh, well, no. First of all, it's HTTP. It's not HTTPS. Yes, your requests are not encrypted, which means third parties can read the data on the wire. Anybody here use Wireshark TCP dump? Yep. Basically, it's a packet sniffer. You can sniff network traffic and read what's going on inside it. So yeah, this is a great way to practice that if you want to. But not only to do that, third parties can issue curl requests to the data, including updates and deletes. So exactly as you said a second ago, people can then issue malicious requests and affect your data. Everybody here curl familiar? Yes? Yes, yes. Okay, good. wget will work as well if you're interested, although you can't write with wget, I think. Of course, because people can then access your data, that will allow for potential data leaks, obviously, and also potential ransom attacks. I come in, I have the ability to upload your data, I read your data, I encrypt it with my key, I save it back to your database, and because your database has over 10 billion keys, you didn't notice for the first 5 million I did. And of course, there's user permissions as well, which is another issue. So, by default, OpenRiak has one user for everyone. Yay, nice and easy, simple, straight work out of the box. But of course, that means anybody can read anybody else's data, which means anybody can update or delete any data. You see where we're going with this already, don't you? Which allows for potential data leaks and again for potential ransom attacks. So these are out-the-box problems you encounter with OpenRiak with a default setup. What can we do about them? So default remedies. So well, EPMD, it's a shared cookie, everybody knows, so change the cookie. If my password is no longer Open Sesame, it's something else, then nobody knows what it is. So yes, security by obscurity, technically that's true, but it needs to be there for the nodes to work together. And if you have a cookie that's maybe 64 characters long, by the time someone's brute forced that, you should probably have noticed if you've got people running decent network security on your system. HTTP, well, install an SSL, and it's HTTPS. Yeah, that's a bit of self-one. So on the plus side, that does secure the connection so people can't listen, but it also means that they can still do direct reads and writes, just their direct reads and writes are now secure. And finally, user permissions. So Riak has a whole suite of things inside it called Riak security. And what this allows you to do is essentially not only enable user permissions, and you create users, they can be user password, you can do it by IP address, you can do it by talking to, for example, some kind of database to get your users. You set it up many different ways, but essentially you can prevent access without a valid user. And other things you can do with it, which is also kind of cool, is you can say, for example, these buckets, any user can use it, but they're read-only. Whereas this user is allowed to write to that bucket because they're special. So you can do very granular security settings, although that does take a while to get the hang of. But why is that still not enough? I mean, we've secured the requests, people can't guess our cookie anymore because it's obscenely long, connections are secure, and user can't log in. Why? Well, users can, of course, log in. Non-users can't log in. Why is that not enough? What have we missed? We secured everything. So, connections to OpenRiak are now encrypted. I come in via the HTTP API or the protocol buffers, as that's already done for us, and it's encrypted. Yay! And of course, we require valid credentials to talk. So yeah, that's kind of good. I need a username, a password, and an encrypted connection. You know, that sounds pretty secure to me. But as we talked about earlier, OpenRiak is a distributed database. What do distributed databases need to do?
Distribute data.
Exactly. They need to sync the data between the nodes, and the Erlang connections between the nodes are not encrypted. So people can't listen on the wire for the user queries, which is sad because those are the really easy ones to get into. But if you listen to the data traffic between the nodes, you can actually work out what's going on and theoretically steal data from there. That's a whole level higher to do, but it's still doable. What else do we have issues with? Well, OpenRiak runs on open regular Linux servers. Download all that, but it doesn't matter. OpenRiak runs a large code base with many ports in use. Anybody see where we're going? I got a feeling we do, yes. So in IT, new attack vectors are being discovered daily. Zero-day exploits happen, even in our latest release, which is actually 2 days ago, although we haven't finished the packages yet, so you'll see that next couple of days. But third parties may try to access the server ports directly. Maybe they found a new hack, maybe they found something else, we don't know. And we can't really secure against stuff we don't know about because it's hard. Right. And what else do we have? So, another classic one with OpenRiak. OpenRiak, like pretty much every other database in the world, we need storage. We need to keep your data somewhere. Many companies run OpenRiak on their own hardware. Can we see where we're going? Physical hardware can be stolen. What's on this server? I don't know. Let's take it home and find out. And that's an issue. So yes, even without the OpenRiak usernames and passwords we set up a minute ago, if you steal the storage device, you can read exactly what's going on inside it. So how do we deal with these harder issues that we've just encountered? I mean, we've locked down the database itself, but there are still vulnerabilities we didn't cover. So what else can we do? Well, secure even more. Connections between nodes are not encrypted. Any solutions?
Encrypted.
Bingo! We encrypt them. So for the moment, point-to-point VPNs or tunnels. That will work nicely. Third parties are accessing my server ports directly. Solution?
Only allow. You don't allow inbound traffic or allow rules.
Yes, there we go. Firewall rules. Turn on the firewall. Say yes to you, but no to you. You're naughty. Don't trust you. Physical hardware can be stolen. What can we do about that?
Shared responsibility.
Better security.
Bit more specific. Both of those are true, but yes, how do you make it more specific? Thank you. Yes, we encrypt your OS or your data. Awesome. So yes, that's essentially how we secure it, and everybody knew that. Why are you here? Come on, that's the main part of the talk. But let's talk about that in more detail. So tunnels or VPNs. Incidentally, OpenRiak runs on OTP 28. That's the version of the line for those not familiar. No, we don't run on 28. I apologize. Currently, the live version runs on 24. 3.4 will be released in late autumn this year. That will run on OTP 26. Unfortunately, encryption for free between nodes doesn't happen until OTP 28. So you'll probably have to wait for version 4.0, which will be next year, I expect. So, we have a solution in the works, we're just not there yet because the programming language we run on doesn't support that yet. But we will be there. In the meantime, you can use open source applications such as Tink. Anybody familiar with that? Okay, it's a standard Linux tool. You should be able to get that with your local distribution at install Tink or DNF install Tink or whatever your zipper, whatever your local package manager is. That should probably be able to get you Tink straight away. It's very simple setup. I'll be perfectly honest, it's not the most secure tool out there, but it's better than nothing. From there, another one you can do, which is also free with most people's distribution, is StrongSwap. And that gives you, it's harder to set up, but it gives you IPsec between nodes. In this case, in these cases, what you want to do is you have to set up your tunnels first, and then install OpenRiak and cluster it afterwards, which is a bit of a pain to do retroactively, as you then need to redo a whole bunch of stuff, which is an absolute nightmare. But if you're doing it in advance and thinking about your system, then this is the way to do about it in production. Of course, firewall restrictions. So we're talking about open source tools. Well, you're probably running this on Linux, which is open source most of the time. You might be a Red Hat person, but your Linux install should have a firewall. So use your firewall, basically. Third-party firewalls are also available. You can pay for these, or you can use software ones, hardware ones. There's all kinds of wonderful stuff out there if you're looking for it. As mentioned earlier, we should restrict the firewall to known IPs and relevant ports only. For example, application there needs only the API. It does not need access to EPMD. One of the classic strategies I've seen employed in some large organizations, make sure that everything can talk to everything else within the organization. Great, but if my application layer suddenly knows where all my ports are in Erlang and somebody hacks the application layer, am I happy with that? No, not really. And last one, encrypting your data. So encryption at rest is the classic one people talk about. There are two ways to go about this. You can encrypt your data directly via the application. So my application runs some data, it encrypts it, and then it stores it in OpenRiak in an encrypted form. Plus side, that's more secure because if somebody runs off with your OpenRiak server, even if they started up, the data is still encrypted. And as the keys are in your application layer, they can't access your data because it's all encrypted. Huzzah! Problem with that is, if you're trying to do something like a range search, for example, find me all data between 2010 and 2020, I can't do that because my metadata is encrypted, so I don't know what it is. That gives you then two compromises. You can either choose to store your data in a non-encrypted form, which if somebody's stolen your data means they can do a targeted search to find which data they need to crack the encryption for, or you can encrypt it and give up on that functionality. That's a bit of a trade-off. Choose the lesser of two evils for what you're building. On the plus side, metadata that's one-to-one matching, for example, find me all the cities named in all the cities in Japan. Well, Japan, I just encrypt that and put it in the search, and because that's the metadata encrypted will match the metadata encrypted. That will match, so that will still work. And it brings me back to encrypted data, and I just decrypt it, and there's my list of cities. So yes, oh yeah, will impact free search. True. Other way to do about it is encrypt your disks. For example, file system encryption. I think ZFS is a popular one now that allows you to encrypt it. But that does have a minor problem of if they access your box while it's running, decryption is automatic. Yep, if they hack your box while it's running, decryption is automatic. So yeah, you have to choose again lesser of two evils there. On the plus side, you still get your full search functionality if you have disk-based encryption. But then again, if it's stolen or they access it while you're live, you're in trouble. So I seem to have gone through today's talk slightly faster today. So let's follow the logic. What actually happens in this process? And this process, which is what I apply to not just OpenRiak, but to applications in general, here's an insecure application. This could be anything. It could be a web server, it could be a mobile app, it could be anything you want, we don't mind. So what should we do about it? Well, let's go check it out. Does it have any security tools we can use? Some do, like OpenRiak. Yay! So yes, use the tools. So we'll change out our cookie and we'll add SSLs and we'll create users and we're kind of safe. But are we fully secure now? No, certainly not. Okay, so what do we do next? Well, let's try and identify and fix the areas using third-party tools, as we talked about. You can use IPsec connections, or just use tunnels, or whatever. We can encrypt our file system, or whatever we choose to do. So now, let's have a look at that further detail. Is the OS fully secure as well? And that's part of where we use the extra tools. So we identify and fix insecure OS areas, which is, yeah, file system encryption is technically an OS area as well, which probably needs to be fixed on both sides. Firewalls, again, that's more OS side as well, but can also be application level. So that takes us through. So test, and I cannot emphasize this enough. Test it yourself. Ask your mate to test it. Pay a penetration tester to break into it for you if you've got the budget. Seriously, test your stuff. It costs you a lot to test, but it costs you a lot less than having your system go down or having your data stolen. Is it secure now? No. Do it again. So we run through our entire process. Are we secure now? We're back. We have our insecure application. What else can we do? Is it secure now? Well, yes. Really? Let's do it again. And this is what I mean. We need to keep doing it. Security is always a PDCA cycle. Even if you fix it once, you'll need to come back and fix it again and again and again, because no matter how well or how secure your system may be, chances are somebody's trying to break into a similar piece of software running similar code soon, which will be made publicly available on the dark web, and they'll use it against you in future. So yes, it's a constant stinky pattern we have to fight because there are nasty people in the world, and I really wish there weren't, because things would be so much nicer. But anyway, assuming you do make it secure, yes, and we finally finished, woohoo! And this process should actually be your standard software process testing for security on anything you use. So, I've actually come through this a lot faster than I expected. So let's do a quick wrap up with Q&A. So today I gave you a quick introduction to TI Tokyo, saying, why am I talking to you? I believe I know something about OpenRiak, and I believe I know a little bit about training, but you may have other opinions. We talked about what is OpenRiak and why, when we should use it. Also, why is pretty cool, but when, yes, it has some great applications. Do not use it as a replacement for your SQL database unless you plan to seriously rewrite your application. I will say that. We talked about potential threats, different ways people will come and attack you, or things are at least open too much. So we talked about using built-in tools and tuning on how to get by those. We also talked about using external tools, and it's surprisingly simple. mean, given how complicated this database is, what did we actually do? Well, external tools, well, we secured the file system by encrypting it, and we added tunnels. That wasn't hard, was it? But simple stuff like this, people miss out on. I mean, the number of times I've worked with production systems for major clients, and they've, what? One of Japan's biggest data companies, which everybody in this room will have heard of, but I believe I'm not allowed to name despite the fact they're a customer, they run a full desktop environment on their OpenRiak servers. I don't just mean full desktop environment as in here's a screen. I mean as in it has everything from a development suite to audio codecs. That's the kind of level of wow. And it's really shocking how much people do this. It seems to be really odd, but from people I've worked with and talked to, the larger the organization, the less thought goes into IT. It's as if, you know, here's a $5 million project, and we outsourced it to this company, who outsourced it to this company, who outsourced it to this company, and every single layer took a margin. And there's just one small board sitting somewhere who actually wrote this huge application for this company, and they use it. And you look at the source code, and it's a piece of rubbish. And that's how things seem to be in the world these days. People need to think about things in more detail and do it properly. I mean, don't get me wrong, some companies do absolutely awesome stuff and full respect to them. But lots of the ones I've worked with are absolutely terrible. You occasionally get the, you know, the diamond in the rough. Wow, you guys are awesome. A bit like the bank we work with. They are awesome. They do really good stuff, and I'm most impressed. They give us challenging questions and go, that's a great question. We'd love to answer that because we never thought of that. We'll find out for you. But yes, really get into looking at all the different options, and some of them are surprisingly simple and just aren't done for some reason. Anyway, that brings me to the end of our talk for today. We're slightly before time, but bear with me. If you would like to talk to me, that's me. If you'd like to get involved with OpenRiak, come and check us out. Here's a whole bunch of stuff. Please feel free to take a photo of the slide if you need to, or not if you hate me. If you're wondering what the QR code is for, we're doing a sweepstake at the moment, and as you notice, our company character is Chio-chan. If I was an organised person who was reliable, I would have not left the doll on the desk at home, and instead would have brought it with me. So what I had to do is create an extra slide. This is Chio-chan, who you can win. You fill in the survey, there's a chance. About this big for reference. Yeah, all Japanese companies have to have a mascot, so that's ours. So, complete survey, you have a chance to win your own Chio-chan. They're very rare, there are only 10 in existence. So, yeah, collectible item. And yeah, that's about it, really. If anybody would like to ask any further questions, please feel free, open the floor. Ooh, one other thing before I forget. People may be wondering why, if you go to our website, we don't have Chio-chan anywhere. That's because our website's currently being redone. Assuming that Alton Tab is actually going to work with me, that's our new website, which does have Chio-chan lurking in here somewhere. There's, yeah, nice. Yes, she does lurk in. This is the draft of the new one. This is not live yet. So that's where she is, and she's not there now because we haven't got our website yet. Other than that, oh yes, I'm also going to talk to you about this. Today's one will finish here after, if you're, no. Yes, here we go. After today's talk, there will be an event apparently in YC Conservative and Newtown. These are directions. Go check it out. I'm afraid I need to run away and jump on a plane as I have a meeting tomorrow I need to attend in Tokyo. But yeah, there's a ridiculously long webpage with arrows. This easy to remember link is at the top of the screen. Good luck! Other than that, yes, I'd say thank you very much. I'm Nick Sanders on behalf of TI Tokyo, and we have Yuan, who's been great with all the audio visual stuff earlier, especially telling me that I might get turned off. So thank you very much. Any questions?
Yeah.
Go for it, please.
Disk encryption and nodes talking to each other.
Yes.
Does OpenRiak provide that as a configuration where you can decide that you want to write the data in an encrypted format?
All right. If you want to write an encrypted format, that's done at application level. So you tell your application, encrypt this data, and then you send the encrypted data to OpenRiak.
So there's no configuration.
There's no fancy configuration at all there. OpenRiak is incredibly flexible in that you can store anything. For example, let's say in OpenRiak things are usually stored by buckets and keys. So let's say I have a bucket called user, or maybe even better username. So user ABCD. And then within that, you'd have, for example, first name, family name, date of birth, and avatar. And that will be text, JPEG, or text, PNG, or even a video. And it can store things quite happily like that, which gives you a lot of flexibility to do what you want. Of course, if you're going to encrypt those, you then have to write. You can choose whether or not you encrypt the names, but provided you're able to decrypt from the application side, then that's entirely up to you. So you could do encrypted username, encrypted family name, then encrypted data, or you could actually have username ABCD, family name, and then just store the family name and encrypted data. That's entirely up to the user level.
And then you're also saying something about how if you already have an existing database that's running SQL, you wouldn't want to reuse port this over, migrate this over to OpenRiak. What's the reason for that?
That's an interesting question. That's a bit double-sided. So long term, that's probably a genius move. Short term, it's absolute suicide. The reason for that is that SQL will use things such as joins and unions and all kinds of stuff to do huge queries. I mean, one of the biggest differences between SQL and NoSQL is SQL will allow you to do huge queries which process huge amounts of data and then give you one big result. NoSQL, on the other hand, will usually allow you to do blindingly fast queries, but you can't do complicated queries, which means that you can't just, for example, in SQL, you can probably move from MariaDB to Postgres to Microsoft SQL Server. And you'll need to do a few tweaks to your code base, but it's not that hard. However, if you want to go from Postgres or whatever to OpenRiak, you have to rewrite most of your code base because the queries will just be completely different. So if you want to do a join in something like OpenRiak, what you will probably do is you do a secondary index query, and you do another secondary index query, and then you do a MapReduce, and then return the results from that. Or if it's a simple join, you just send a whole bunch of gets to OpenRiak in parallel. I mean, that's the nice thing about it. The gets are in parallel. So if I chuck 1 million gets at OpenRiak, it goes, yeah, okay, here you are. And because they're in parallel, every single get is as fast as the next one, which means that instead of going get 1, get 2, get 3, which in SQL is a nightmare. If you do query A and then do query B and query C, it's going to take forever because the to the database, back from the database multiple times takes forever. Whereas in OpenRiak, you do it in parallel. There you are straight away, and then you just process it, the application level in memory. But one of the interesting ones that I am starting to see is people using hybrid systems. So stuff that gets hit a lot in SQL, but doesn't actually need SQL's level of complexity. So let's say a user sign-in form. What do? Well, I set my bucket name as the username, for example, user ABCD, as we did a second ago. And as the key, we then have password hash, and then we store the hashed version of their password. Now in SQL, what you do is you go into your user table, which maybe have 10 million users, and then you do a lookup and you find the right user, and then you scroll across and you find the password, and then you take both of those back to the application and match them. In OpenRiak, you just say get, thank you, I'm done. Because in that query where in SQL you need to do where username equals this and password hash equals that, in OpenRiak, I just say, well, get me the hashed password for this user. And if I get a not found, it's not a valid user. And then once the password hash comes back, I then just compare that to the password hash I've hashed locally, and it's a valid password, let them in or don't let them in. So, simple functions like that, you can migrate from SQL to NoSQL really, really easily. Same level of update username, update password, that's really easy. Yes, basically it's just an update operation. You just need to change your query from SQL to NoSQL, and you're good to go. But very, very complicated queries that rely on joining multiple tables together, a classic one where you've got a 10-line SQL query, that is something you probably don't want to migrate to OpenRiak without really, really rethinking how to do that query in a way that's, SQL is essentially it's Excel, isn't it? You've got a whole bunch of tables and you switch between the sheets because you're switching between tables. There you go. It's essentially, you can think of SQL as that. If you want to think of OpenRiak or NoSQL, think of it as a file system. So, you know, you have, well, if you're in Windows, I don't know, C, users, my user, my documents, and then my value or my file or whatever. That's essentially what you can do with NoSQL. And to try and switch from SQL tables to NoSQL bucket type storage takes a bit of a mind shift. I mean, to make it work well, if you store as you plan to query your data, then NoSQL is absolutely amazing and the speed will blow you away. However, if you go for the more SQL-y approach, well, if we just dump all the data in this logical table and then write a query that's such a, because our data is stored in such a weird way that we have to join together 7 million tables to get the answer. That's not an OpenRiak style, a NoSQL query you can do. That's just nuts. That's, well, if it's that many tables, that's clearly bad system design. But NoSQL, think very carefully about how you're going to query it. SQL, think how you want to store it so it's easy to query anything. Which is why one of the secrets to successful NoSQL usage is actually data duplication. You'll often see ones where, let's say you have a username and an email address. So you do a lookup of, you have bucket's name is user ABC and then key is email. But then you have another one that bucket name is email and username is ABCD. So our data is duplicated. So rather than having to trawl through all the usernames to find the email address to work out which user ID that works to, instead I just look it up by user by email address and I can get the user ID straight away. And that's another technical strategy to actually implement NoSQL in an effective way. It's just duplicate the data you want to query in multiple different ways to make so that when you read it, it's blindingly fast. Does that answer your question?
Yeah.
Cool.
So what about migrating from another NoSQL database to OpenRiak?
Right, that depends on the query language used. This will be an ETS problem no matter how you look at it, where you'll have to extract it from the old database in the way they store it and then put it in OpenRiak in the way that you store it. It's fully doable. I know of migration from Dynamo to OpenRiak because they wanted greater performance. Yes, we can actually say that. Isn't that cool? And I know the decision to go the other way because even though they knew they would lose performance and it cost more money, they didn't believe in open source software. They prefer to have somebody else they can blame. You know, the system went down, it was our engineers' fault, sorry. They didn't think that was very good. Rather, well, it went down, but you know, it's Amazon. And even if you try to blame Amazon, they say, yes, but there's a more expensive tier that you could have had and it wouldn't have gone down. And even when you're not, and you get right to the top, they say, well, actually, there's another one, it's just not published. But, you know, if you can blame Amazon and Amazon say, well, it wasn't us, you just paid for a cheap one, then, you know, it's nobody's fault and the press will let you get away with it. Whereas if your system goes down and it's your engineers, you tend to get blamed. So that's why people will sometimes move from OpenRiak to a paid solution, simply because they want to be able to put the blame on someone else. Yes, exactly. Anything else? Okay, fair enough. I'm going to say thank you very much, all of you. If you're up to the events, please enjoy the evening. Yeah, thanks for coming. And I'm going to stop the recording here. Yes, no questions.